Hello, my dear students. Welcome back. I know your exams are just around the corner, and you're all studying so hard. So let's just take a quick 5-minute break to completely master one of the most important topics in your stats paper, correlation. I promise you, by the end of this, you'll think it's the easiest thing ever. Just think about this for a second. When it's super hot outside, what's the one thing you feel like having? Ice cream, right? So the hotter it gets, the more ice cream gets sold. You see that? That connection, that relationship between two things, that's exactly what correlation is all about.
So, this big word, correlation. It sounds heavy, Hannah, but it's really not. It's just a simple way we, in statistics, look at the connection between two different things, or, as we call them in our subject, variables.
Now, for your exams, if you need that perfect textbook definition, here it is. Correlation is just a tool we use to ask a very simple question. When one thing changes, does another thing change along with it? That's really it. That's the main idea.
You've all seen this happening at the local Subzi Mandi, right? When the farmers bring in trucks and trucks of tomatoes and there are just mountains of them everywhere. What happens to the price? It just drops. One day it's 40 rupees a kilo, the next it's only 10. That is a perfect, real-life example of a relationship between two variables, the supply and the price.
Okay, so we know things can be connected. But how are they connected? Do they move up and down together, like best friends holding hands? Or does one go up when the other goes down, like total opposites? This is what we call the direction of the correlation. Look here. On the left side, you see positive correlation. Think of them as best friends. Both things move in the same direction. The more hours you study, the higher your marks go. Simple. And on the right, we have negative correlation. Here, they're like opposites on a seesaw. They move in opposite directions. The more the tomato supply goes up, the lower the price goes down.
But what if you're a visual person? You don't want to mess with numbers right away. You want to see the relationship first. Well, guess what? There's a way to do just that, and it's called a scatter diagram.
A scatter diagram is honestly like taking a quick photo of all your data. You just put all your little data points as dots on a graph, and then you take a step back and you look for a pattern. It's a really simple but really powerful first step. Okay, have a look at this first diagram from your textbook. Do you notice how the dots are generally moving in an upward direction? From the bottom left corner up to the top right? That upward slope is a clear visual sign of a positive correlation. And what about this one? What's happening here? The dots are trending downwards, aren't they? From the top left to the bottom right. This is what a classic negative correlation looks like. And finally, look at this. The dots are just all over the place. There is no pattern, no direction, nothing. It's a complete mess. This, baccho, is what it looks like when there is absolutely no correlation between two variables.
Okay, so pictures are great for getting a general idea. But, in an exam, they want a precise number, a single magic number that can tell you everything, the direction and the strength of a relationship. And for this, we have to thank the genius statistician Carl Pearson.
Pearson gave us this thing called the correlation coefficient, which we just call R. Now, this number will always be somewhere between -1 and +1. The sign, if it's positive or negative, tells you the direction. And how close the number is to 1 or -1, well, that tells you how strong the relationship is. This scale right here is probably the most important thing to remember about R. A +1 is a perfect straight-line positive correlation. A -1 is a perfect -1. And a 0 right in the middle means there's no linear relationship at all. Anything in between, like a 0.8 or a -0.7, that shows a strong relationship. And numbers closer to 0, like 0.2, show a weak one. Okay, enough of theory. Let's get our hands dirty with a real example, one from your textbook. So the question is this. Is there a relationship between how many years a farmer went to school and how much money they make from their crops? So here's the data we have for 7 different farmers. X is the number of years they went to school, and Y is their annual crop yield in thousands of rupees. We're going to use this very data to calculate our magic number R. Now, after you plug all these numbers into that big formula, which you must practice for your exams, okay, we get our magic number, and that number is plus 0.644. So, what does plus 0.644 actually mean?
Well, first, it's positive. So that tells us that as education goes up, the crop yield also tends to go up. And since 0.644 is a pretty good distance from zero, it means it's a moderately strong relationship. So this suggests that, yes, education really can make a difference for our farmers.
But what about things that you can't really put a number on, like how beautiful someone is or how honest they are? How can we find a correlation for qualities like that? For that, we need a very special tool.
I mean, you can't say someone is an 8 in honesty, can you? That's silly. But you can rank people. You can say this person is the most honest, this one is second, and so on. When you're working with ranks instead of actual numbers, use something called Spearman's rank correlation. For now, you just need to remember the name.
All right, let's do a super fast recap. These are the absolute golden points you have to remember for your exam, so focus up, okay?
First, R is always between -1 and +1. If you get an answer like 2 or 3, you've made a mistake somewhere. Second, R has no units. It's not in rupees or kilograms or anything. Third, a positive R means they move together. Fourth, a negative R means they move in opposite directions. And finally, if R is close to 0, it means a weak relationship. Got it? Good.
And now, for the single most important thing you need to take away from this entire chapter. I am serious, Butcho. Never, ever forget this. Correlation is not the same as causation.
Let me give you a famous example. In the summer, ice cream sales go up. At the same time, sadly, the number of people who drown also goes up. So there is a very strong positive correlation. But does that mean eating ice cream causes drowning? Of course not. That's ridiculous. There is a hidden third reason, the summer heat. The hot weather makes people buy ice cream, and it also makes them go for a swim.
And that's it. That is everything important you need to know about correlation for your exams. I know you've all been working so hard, and you are going to do great. You've totally got this. All the very best.